Hello everyone, welcome back. I know this has been a crazy long series. When I was editing, I was like, I can't put all of this in one video, so I split them in 3 videos. But anyway, in the first 2 videos, you looked at the appearance of Comfy and Grasshopper, the interface. We looked at where to install the plugins. We looked at certain plugins that are very important. Then we also looked at what is nodes, how do you connect it, what is the group, color coding, and things like that, right? Now, in this particular video, we will be only focusing on creating one example. So we will do some kind of a geometry from Grasshopper. We will take an output from it and then we will connect to ComfyUI. And we will look at some of the details of KSampler and what is Clip as well to understand how the base workflow works. So let's get right into it. Now let's just make something in Comfy, and I want to tell you details about what these things are, which is like KSampler and things like that. So I'm going to delete all of this. So you can just hold Control in Comfy and delete it. In Grasshopper, you can simply do Control A and delete it, or you can just select, drag on it and delete it. Either way is fine. Now let's take the default script of Comfy. So if I go to these 3 lines, workflow, templates, I say this one. So again, because I changed my wire to straight, now it is straight. I will change this model to Excel Real Viz, which we downloaded. Then you have to change this resolution as well. Right now it's 512 by 512. Change it to 1024 by 1024. So it's more of HDXL resolution. Then now let's see this component, what all of these mean. So as you see, this is what the base workflow looks like, where you have your checkpoint model, you have your prompts, you have your image resolution, which depends again on, like I said, HD or HDXL or whatever, and then this KSampler. Few of the important things that we need to understand in Comfy. One is what is called as this VAE. So VAE basically stands for Variational Autoencoder. If you remember from my How Prompting Works video, I told you there is something called as a latent space. Now what VAE does, it has all of this data that has been trained on. So when a prompt is generated, or when we give a prompt along with the settings, it goes through the encoder in that latent space and then it decodes it. So what it is doing, it is taking all the information from these two, from this part and this part totally, where this is called VAE, and that's why we downloaded a model that has already baked VAE in it. Otherwise we will have to again separately download a VAE. And here we will use a VAE decode. So whatever goes inside of that latent space, that's get decoded, and that's basically what VAE is. Then I just want to bring that slide what I was talking about, latent space. So this is what I was telling you in the 2 videos before, which is what this latent space looks like. So there are things that are arranged because AI does not understand words, right? It has to convert it into tokens, and those tokens then kind of get converted into a vector. Now, who does this part? So this is what is happening, right? When you generate image, there is first a random noise, then there is a prompt vector or a guidance. For example, let's say in here, all of this, whatever you define, there is a new thing that is created here. Your prompt gets created in this new vector. For example, you're creating something like a wall. Let's say it's like a dry wall made of marble, has a sculptural feel to it. So it kind of comes at the, not at the intersection, but kind of what is more near. And that also depends on what you use first in the prompt, right? If you remember from the cherry example that I gave in my How Prompting Works, the first video gets the more weightage than the other one. So in this case, let's say I want to make a wall that is made of marble and has a sculptural feel. So this is new vector that is generated. Now, who does this part? This part is done by Clip, basically, which is called as Contrastive Language Image Pre-training. So this part helps AI convert the tokens or convert the text into tokens into that particular vector into the latent space. So that's why it's called Clip and not just prompting, which we generally, if you use Midjourney, this is also what's happening in the back end of those tools. Whenever you prompt something, those gets tokenized and then converts it into a vector in that latent space. So in simpler terms, you can understand Clip as a connection between text and image, because it converts into a vector, it goes in that latent space, and then we get something out of it. Now, there are a lot of other things that are happening here in KSampler. So in KSampler, you have first one, which is called a seed. Seed, like I told you in my earlier video, is a random number. For example, let's say you prompt ice cream, then it will give you one image. then the next time the seed will change, it will give you different image of ice cream. And that's what seed works like. Then control after generate means what is the next seed you want. For let's say example, you liked one particular seed. Let's say you liked the seed 25. Now you want to see the next iteration. What you can do, you can change this from randomize to increment, which will be 26. Or you can say decrement, which will be 24. Or you can say totally random. Then comes steps. Now what steps means is that how many times the prompt runs to generate an image. Then CFG means how close is your image to the prompt. So steps mean how many times it is running and how close it is to the prompt. We will see visually how this looks like. Then what is sampler? Now basically you can imagine sampler as what algorithm it is using to denoise the image. For example, sometimes it uses very precise model. Sometimes it uses a little bit of a creative model, and this depends on the model that has been trained. You can imagine this as, let's say you have a painting is done on a wall and there is dirt on it. Now you can use various ways of how to use it. You can use a paper, you can use a scrub, or you can directly pressure wash it. So that's what this does, what algorithm it's using. And then scheduler controls the noise level change. So basically, what it does, let's say at the first go, you want to remove that dirt. Are you going to do quickly, very quickly first? Or are you going to do very slowly and then do quickly? Or are you going to keep the same speed throughout until you get the image? So that is decided by scheduler, controls how the noise level changes in every step. So are you going to do it very fast? And this also then changes the output. And then last is denoise, basically, which means noise reduction. So basically, you know that image starts with zero noise, right? Which basically it means it's a blank canvas, and you keep on adding noise to it until you get the images. So just to see this more visually, so this is how it looks like. So with denoise of 5, you hardly see any image. You see only glimpse of the prompt. But as you increase it to denoise 1, you get to see the output much better. So that's how denoise works. Then what I was talking about sampler is what algorithm it is using. And with each sampler, the output kind of changes. For example, some might be very precise. Now these might be more creative. They're adding more shadows of trees onto that particular building. Now with scheduler, like I said, it looks very similar. Like most of them kind of look very same. It depends on the details that have been added. Sometimes what happens with some scheduler is that you end up adding details in the beginning, and then it's only creating the image. Or in some scheduler, you start creating the architecture first and then the trees. So it depends on the scheduler that have been used. The most important 2 parameters that I keep on iterating or changing a lot is this CFG and steps, which I told you is steps is how many times the prompt runs, and CFG is how close the prompt is. So for example, with CFG1, you will see that you get the same images, right? All across the board, the images is same because it is not getting closer to the prompt. It is just running with a little bit of closeness. As the steps increases, you start getting clearer and clearer images. But we always need to find what is the correct mixture of these two. And in this case, I think these 2 images are really good. These 2 with CFG of 7 and steps of 10. It's also important to note that just because you crank these values up, it's not going to give you a good image. For example, you see the next image, right? There is a purple shade to it. You see here at this corner as well, there is a purple shade to it, which means that it has gone way more, right? It is emphasizing the prompt so much, it has gone way beyond. So we got to have a balance between CFG and steps to get a much nicer result. Now you might be wondering, this is so technical, like why would I even want to learn this? But don't worry, whoever trains the model tells us what to use, what steps and all of this to use. So whenever you use a checkpoint model, we went to CivicAI, which has a lot of models. When you take each of the model, below that, you will see what sampler to use, what scheduler to use, what is the steps and what CFG to use, because they have used that to train that model. And if you use anything else, you might not get it close to it. So whenever you download a particular model, always note down these things, right? Or you can of course go back to the internet and see, but note down these things so it's helpful to put in the prompt. And like I was saying, when I was showing in CivicAI, these are some of the models that I like the Juggernaut one, then Realistic Vision. There is Open DALL-E model also, which is also sometimes gives a good result. Then there is Fantasy World, which sometimes makes, fantasy images really nice. Then I also like sometimes to use a little bit of illustrative cartoon design. So I use this Toon U. But anyway, this is kind of what's happening inside that mixture of the prompt. So whenever you give this particular prompt, here the text is first getting into a vector to go in that latent space from where it will decode, and then you get the image. And then with each of this KSampler, it is using different ways of reducing the noise. So you don't need to know precisely what it is. You can go to Civit AI and then see what kind of noise works well. Now let's just do a simple task, simple thing. Okay. So firstly, I will run. Now I don't know, I might get freezed again. I'm going to run the same prompt that we did last time, right? Now with this, we are using the different model. We are using Excel model. So I think the prompt was cat sitting on a balcony, and I will run this. It takes time to load the checkpoint model, but it should do it fast. Yes. You see something like this is happening. What is this? This looks new. I'll tell you what it is. Okay. And isn't this better? Isn't this image much better than the previous one, which we were using a HD model? Now this is HD Excel model. Now you might have seen something started generating here. What was this? Why was this? So if you want to see a preview of what's going to happen, and this is helpful when there are multiple steps. For example, you sometimes create an image, then you want to upscale it, you want to change the little bit of details. Then this is helpful that you can cut it off in the first go as well. So to do this, you got to go to manager, and you see there's something called preview method. You can change it to whatever I've kept it to auto. Generally it's set to no, which means that you will only get the end image. You can also set it to slow or fast. If I keep it to auto, then this is what I get. So you will see a preview of what's happening. You see the resolution is half of the output resolution. Now let's see how to take an image from, we'll do a simple task from Grasshopper, take an image and then convert something, I don't know. So in Grasshopper, I don't want to go into scripting today, but I do like this particular plugin called Lunchbox, which kind of comes with some pre-forms, right? You see this, there's some, if you go to Lunchbox, if you go to form, you see there's some pre-forms that are already generated. Maybe I'll take this enable surface, right? And that kind of generates this surface. And this looks nice, like a minimal surface. Like I said, I don't want to go in detail into scripting today. For this video, we'll see for the next one. So this looks nice. Now we'll take an image of it. This is really crucial. How do you take an image of it? Let me bring my Rhino here. So generally what I like to do, so whenever you are in Rhino, right, if you want to work with one view, you double click on that. Let's say I go to perspective. I generally like to go to rendered view, or I like to go to monochrome. But you will see this, what's happening. Like, why can't I really see what is going on? What's actually going on here? I have no idea. This is because this geometry is not in Rhino. This is in Grasshopper, which means if I click, it's going to be pink. I have to bring this geometry into Rhino for me to get a better render, or let's say to add materials and things like that. To do this, we have to bake it. As simple as that. So you can right click on this component. You can say bake. If you have multiple layers, it will ask you which layer you want to bake it in, and then you say okay. And now you will see, let me preview this off. Okay. And now you will see we have this model completely inside of Rhino. Then what I like to do is, perspective is not really good. So what I like to do is, besides perspective, you see there is a small tiny arrow. Click on it, then go to set view, and then I'd like to go to 2-point perspective. I feel like this gives much more better result. So I always like to go to 2-point perspective. Let's say, what's a good angle? I think this is a good angle, right? Yeah. And then the difference between, you can also check the different styles. So with render, what happens, you don't get that outline, right? Sometimes what happens for Comfy, it's not really understandable what's the difference if they're same materials, because in this case we'll not go in details of understanding ControlNet and things like that. But when you use something called as a monochrome, you get a line around the geometry. So for Comfy, it's easier to understand, okay, there is a defined geometry here and this rest is just a background. Then to take an image of it, you do Control P on your keyboard. This will bring out this panel. I like to keep my images at the resolution of 960 by 1200. Like a vertical one. And then what you can do, so first thing you got to change here to image file, change the resolution to pixels 960 to 1200, keep it to high quality, 300 is fine. And then here you have to set the window. Right now you see the geometry is only here. So I'm going to set it. I will drag it something like this and press enter. So now you see the geometry has become much more better. You can keep on changing it until you feel good. Press enter. I think this is a good view. I will print this. Let me save it to desktop and let's say 1. Okay. You can take multiple views of it. It's up to you. Now let's see how to get some kind of a render out of it in Comfy. I'm going to close this because sometimes if I keep everything on, it's going to take a lot of time to compute, and then I'm going to make Comfy big. So now the part of Grasshopper a little bit done. Now the first thing that we need to do is take that image. So to take that, we use a node called load image. Now here, choose file to upload. Then I'll go to desktop, this one, and I say open. Now you see we have that particular image that we did. But where will Comfy know that this is the image to be used? Now what I like to do, if I don't know what has to be done, just drag a wire from image. And what do I need to do? So this is the new resolution that I need to set, right? So maybe VAE encode is the better one. Now this is asking me what is the VAE. So we have already the baked VAE that's coming from here. Now you will start seeing that when things get little bit more complicated, wires just kind of keep overlapping. So always take a minute just to clean your script. It is crucial. Like, I cannot emphasize more on it. It is crucial for you to keep your scripts clean. So what I like to do, I drag this, I take reroute. So now this goes to positive, this goes to negative. I will double click this. I say this as positive. I can color this into green. I will say this as negative. Then I can color this into red. Okay, we don't need this much for negative prompt. If you feel like you don't even want to see it, you can hide it. I will reduce the size of positive prompt as well. So now this is starting to look little bit nice. Let me align it and then let the model go here a little bit. Okay, then empty latent, right? Now we don't need the empty latent because the resolution will come from the image. So I will delete this. Now this VAE, let me put this here. Let the image go here. Now this has to go to latent. So I will reroute it so that I know where things are going where. So we reroute it here. Let me move that here. This looks neat, nice. Let me move this. Okay, I think this is good enough. So we see that where the prompt is. Okay, we see the positive, negative, right? I can reroute the model as well. So let's reroute the model so that this gets connected here nicely. Okay, amazing. I absolutely love doing this. I don't know how many of you are going to enjoy me doing this on video, but this to me is really important. Okay. Anyway, now you see how clean this looks. I know which wire is going, like amazing. Now I want to change this prompt to, let's say, something like a pavilion. So this is kind of a little bit of aerial view, right? So let me type it like aerial view of a pavilion made of wood in the jungle, and the shape of the pavilion in the shape of curved and organic. If you remember the name of the surface, it was called a Eniper surface. I try to add this generally in the prompts so that if somehow in the training data set this was done, so it's always good to have, right? And now let's run it. Oh, what's happening? Something is happening. Okay, I got this. Good, but there is no inference of the image. Two things are missing. Firstly, we didn't change the sampler and the scheduler to the model that was there. So I think this one will be Keras and this is DPM plus HDE. We can take a look at it again. So this is V4 baked VAE, and you will see that so this is for the turbo and the lightning model, but let me go show more. Yes, so here it says DPM plus HDE, Keras is fine. They're saying 30 steps, 20 should be fine. So let's do that. DPM plus HDE plus Keras. So we change it to DPM plus HDE and we change it to Keras. Now, even if I run this right now, it's not going to give me that image because the denoising is not less. Because for it to take the inference or the influence of the image, this is basically adding already a noise to the latent space, right? Because we're telling the latent that, okay, this is the noise you have to use. You don't start from the blank canvas, start from this image, which means we have to reduce this, right? So let me make it 0.6 and see what happens. Now you see the shape is getting generated here slightly. Amazing, right? It's not going to be 100% accurate shape because we are not using ControlNet, which gives you 100% accuracy. But this is just to get a first glimpse of understanding with how these two tools can work together. Let's see what it looks like. And amazing. I love it. It's good. It's not doing wood because the image is in white. So if you have to make it wood, apply that material in Rhino and it will do it in a wood format. Now again, where this is saved, if you remember from my earlier videos, this is saved in ComfyUI output. So you see, it's saved in ComfyUI output. Now, if you don't want to only have this, let's say you want to add a date to your output, then what you can do, here you see, they will tell you a format. Always, like I said, reading is very important. You see, this is percentage date, year, month, DD or whatever. So what you can do is you can do the same thing. You can say percentage date, then it was year, and then how was it? What was the format again? Month, date. Okay. Then I do dash month, dash DD, and again I do percentage. And in this case, the name of the image is, let's say, pavilion. So let me check if it is correct. Percentage date. Okay, I think this should be correct. Now let's run it again and see what we get. So you see, just from this image, we're getting this amazing looking image. And hardly how much time did it take? Of course, understanding takes a lot of time. I also would like to use another node, image comparer, that comes with the plugin RG3. So like I was telling you, you have to install a plugin called RG3. And this is really good, right? Now let's check the output. And here you see, it's showing me the date, which is 2025-05-14, pavilion 001. Amazing, right? Beautiful. So you can save the images like that. You can also save the images. Let's say I want to know what is the seed value of an image, right? So that I can start from the same way. Of course, you can drag it, but just for example, I want to save it so that I pass it to somebody. Because let's say I don't want to save a metadata. I just want to save that, right? What happens is that, let's say I directly post this image somewhere. Somebody can drag this in Comfy and get the entire interface, which I don't think is a good way of saving images. So what I like to do, say for example, generally I like to know what are the values in KSampler, and nothing much. So what I like to do is that, so this remains same, percentage. So here you type KSampler, and instead of year, date, what you type, let's say, I want to know what is the seed. So I type seed, I say, okay, let me increase this number a little bit and say run. Oh, I love this image. I already love this image. Damn, that's nice. Okay, I get carried away. Sorry for that. It's a bit slow because a lot of things are running on my computer. And I love this. This is without upscaling, and we haven't even used ControlNet yet. And let's say the output, I didn't save it. Oh, it should be dot width. Okay, my mistake. It should not be this. It should be dot seed. Oh no. Okay, you have to type this exactly as it is. So it has to be KSampler exactly how it is. And in this case, I will also want to use the image comparer node. So we can compare image, this one from RG3. So what you do, you input two images. For example, this is image number 1 and this is output is your image number 2, and now run it. Okay. So now with this particular component, let me make it big. So this is the original image, and if I slide over, you will see the new image. So you see, it has taken a lot of clues from the original image and made it into a nice kind of a pavilion, right? It's, again, like I said, it's white because the material has not been added. But with this simple step also, you can do so much, and we are only changing the denoising values. We haven't even installed any ControlNet yet. Now let's see if it is saved the seed value. Yes, you see, now with this image, this is the seed value. If you see here, this is the seed value that it's saved. So with each of the components that you use in Comfy, you can also type the name of the component and what you want to save it. Now, why I was telling you this is important. For example, let's say I share this image, right? This is an amazing image that I really liked. I want to share this. Okay, I want to share this. But what happens, because the metadata is saved in it, whenever somebody, for example, we don't know, right, what anybody want to use it. So if they drag it into Comfy, they will get all your setup. To avoid this, the first step that I do is I save the details like this, which is the details of KSampler.seed, whichever number you want, right? Generally, seed, CFG, sampler, scheduler remain same, or we can find out. What really keeps on changing is the seed value, or the denoise value. That's the two things that keep on changing. So you have to save those two things. Then what I like to do is that I generally just go to Photoshop. It's simple. and then I resave that image. So the metadata gets lost. So I imported this image in Photoshop. Now if I just save it as a JPEG, right, I'm just saving this as a JPEG, export, desktop, let's say it's 1A, enter. And now if I drag this, let's go to desktop again, and this is that image, right? So if I drag it into Comfy, it will say unable to find workflow. So that's what, I mean, I know it's a workaround, but it's easier. Otherwise we have to go in Comfy, code things which might take a lot of time. So what I generally like to do, just quickly open up Photoshop, drag all your images and save them as one by one. You can make a PDF as well, that also works. And if you drag it, it says unable to find. So here it says unable to find a workflow. So that's another way of doing it. But that's mostly what I wanted to cover in this particular video. I wanted to show you all the similarities between Grasshopper and Comfy, kind of understand the basics of the interface, the nodes, and how they work together, right? And you can create a basic geometry, add it as an image, and you end up with getting amazing results. Like how cool are these outputs, right? Not this one. Yeah, how amazing are these outputs? Like this one. So simple with just particular image. I absolutely enjoy it. So that's mostly it. And if you know any more similarities between Comfy and Grasshopper, do comment so even I will learn. So I hope you will like this video. Thank you for your time. Please do like, share and subscribe, and I will see you in the next video.